Dear students, today we will going to discuss about a very important chapter of chemistry, that is carbon and its compounds. What is carbon basically? Carbon is present in the periodic table, which is having the atomic number of 6 and the mass number of 12. Why we study carbon? Because carbon has some unique features, some unique properties it involves. That's why we are studying this, and its compound. So with the carbon, the other elements, how they form compounds. So we will study that also. And in this chapter, we basically, so why carbon? Carbon is basically belongs to the fourth group of the periodic table, or you can say the in the modern periodic table, it is 14th group. Then it is having atomic number of 6 and which is having the configuration 2 comma 4. That means there are 4 electrons in its outermost orbit, so its valency is 4. Either it can form bond by sharing the electrons or by transferring of electrons, that we will study later. But we should understand that if the valency is 4, then it can take 4 electrons to get stable, or it can lose 4 electrons to get stable. So we should remember carbon is a non-metal. Like this, it is present in the periodic table: carbon, silicon, germanium. So it lies in the 4A group. And how the electron is revolving, or how the outermost shell is having 4. So 4 dots, 4 balls means 4 electrons are there in the carbon atom. Where we use carbon in our day-to-day life, we have so many things. In fact, what we are eating also, that is of carbon. There are so many medicines which involve the usage of carbon. Like we cook our food, that also contains carbon. We use so many things, so many plastics, so many things are there at our home, that is also made up of plastics. We use so many fruits, vegetables, that is also of plastic, or that is also of carbon. So the number of carbon compounds is very large. It's a very wide variety of carbon compounds are there. So we study some of them in this. Why so many carbon compounds in nature? Because carbon is chemically unique. How it is unique? Only carbon atom is having, there are two types of properties which carbon shows. One is catenation and other is tetravalency. What is catenation? It is written over here that carbon atoms have the ability to combine with themselves to form long chains. So carbon is having the self-linking property. It is known as self-linking property, which is only present in the carbon, and this is how it does the catenation. So it can form bonds with C only. So C, 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 it can form bonds with itself, right? It can form bonds with itself. So we have so many C. If these carbons, carbon number is 60, then it becomes fullerene. This is one of the allotrope of carbon, where 60 carbon atoms are arranged in the shape of a football. They are arranged in the shape of a football. So this is how, this is the catenation property. Then there are so many compounds over there. We'll study one by one. And as we know, what are the allotropes of carbon? There are two forms of carbon. One is, what do you mean by allotrope? Allotrope is basically there is only one atom which can be present in many forms, like hydrogen present in three forms. Hydrogen present in three forms, that are, one is protium, which is having 1 deuterium, which is having the atomic number of 1 and mass number of 2. Third one is tritium. So these are some forms of hydrogen. Like this, we have total 2 forms are there in carbon, that is diamond and graphite. What is diamond? What is graphite? Diamond is basically what we see over here in our, you can say in ornaments, we can see some diamond stones are also there. Like this diamond can be viewable. So it's a crystal having some crystal like structure, and this is your graphite. So allotropes are basically, these are the elements which are chemically identical, but they are having some difference in their physical properties. Like you can say a diamond, graphite, there are so many things in different, like you can say their appearance, their melting point, their boiling point. Diamond melting point is very high. So like this, diamond and graphite are the 2 allotropes of carbon which is differ in their physical properties. How they differ, I'll show you that. In diamond, what you need to remember is basically in diamond, there are each carbon atom is bonded to 4 other carbon atoms. One carbon is bonded to 4 other carbon atoms. But in case of graphite, one carbon atom is bonded to 3 carbon atoms only. So this is the big difference which is in appearance over here, that one carbon is bonded to 3 carbon atoms. Like in case of this second structure, like we have this one carbon, and this carbon, red piece, is attached to 3 blue balls, 1, 2 and 3. 3 blue balls, it is attached to 3 blue balls in the same plane, giving a hexagonal array. So there you can see this key hexagon is making here, but in diamond there is no any hexagonal structure because one carbon is attached to 4 other carbon atoms. So valency is here completed. Second difference is there are only single bonds present in diamond. All the bonds are single bond, and in case of diamond you can see that there must be always a double bond present over here to complete the valency, because one carbon attached to 3 carbon atom, so there is 1 electron, so 1 electron goes to the pi bonding, means double bonding. So graphite structure is formed by the hexagonal array being present in layers one above the other. Graphite structure is present in layers one above the other. There is little bit much more differences also, like diamond is basically diamond is the hardest substance ever known, while graphite is smooth and slippery. There is next difference also, the diamond is costly and the graphite is cheaper. Graphite is very good conductor of electricity. If you heat the graphite, it becomes very high hotness is there in graphite, but in diamond if you heat it, it doesn't heat easily, it doesn't get hot easily. So it is a poor conductor of electricity. Diamond is a poor conductor of electricity and graphite is a very good conductor of electricity. If you want to synthesize carbon, if you want to make carbon, then you have to put the carbon over a very high pressure, very high temperature, then only the graphite can be synthesized. And there are two kinds of diamonds also, synthetic diamonds and natural diamonds. So synthetic diamonds are very small diamonds, but natural diamonds are basically big diamonds which is found naturally. Fullerene, there are this is the third allotrope of carbon, third form of carbon, which is known as Buckminster fullerene. Why it is known as Buckminster fullerene? Because the fullerene is the shape of this figure and C60, and this is given by the scientist who is US architect. His name is Buckminster Fuller. That's why its name, it's fullerene. So in this 60 carbon atoms, 60 carbon atoms are arranged in the shape of a football. That's why it is named as fullerene. Then we have we little bit study about that the amount of carbon present in the earth crust and the atmosphere is quite mere. There are only 0.02% carbon which is present only in the earth crust, and the carbon in the form of minerals. Carbon is not present individually everywhere, but carbon is present in other forms like carbonates, carbon dioxide. We study that we take carbon dioxide from the environment. So what is carbon dioxide? It's a compound of carbon, again CO2. Carbonate. So carbon is present in carbonates, carbon is present in hydrogen carbonates, carbon is present in form of coal, carbon is present in the form of petroleum, carbon is present in the form of food. So most of the things are based on carbon. And in the atmosphere, there is only 0.03% of carbon. That's why we say that we should not destroy the nature. We should not destroy the trees, plants. And what kind of bonding is there in carbon? There are total two types of bonds are there. One is ionic bond, other is covalent bond. So carbon compounds only do the covalent bonding. What is covalent bonding? Covalent bonding is basically, you can write that there are two types of bonds, ionic compounds, the compounds which formed by transferring of electrons. Transferring of electrons, like in NaCl. NaCl is having Na plus and Cl minus charge. So the bond is formed by the transferring of electrons. Ionic bonds are much more stronger than covalent compounds, covalent bonding. And what is covalent compounds? Carbon do the covalent compounding, right? What are covalent compounds? The compounds where the bond is formed by sharing of electrons. Example, CH4. Methane. It is also known as methane. So this is the definition of ionic compounds and covalent compounds. The compounds where the bond is formed by transferring of electrons. Ionic compounds means the bond is formed by the transferring of electrons, like in NaCl. But in case of covalent compounds, the bond is formed by the sharing of electrons. Like you have one apple and there are two students and you have to divide the apple. So either you give the apple to two of the students equally, means if you cut the apple into two half and you give each of them equally. Or the second case is one student is much more hungrier than the other one. So that student says, give me the whole, right? So that means the transferring of electron. And if they equally divided into two, like मेरे को भी चाहिए, दूसरा student मेरे को भी चाहिए, then it is covalent bonding. So carbon to the covalent bonding. And then ionic compounds have high melting and boiling point and conduct electricity in solution. Most of the carbon compounds are poor conductors of electricity. Their boiling point, melting point is little bit lower as compared to in ionic compounds because the force of attraction is not that much stronger as compared to in ionic compounds. Because in ionic compound there are cations and anions are involved, so there are plus and minus, so the bond is much more stronger. But in case of covalent bonding, the sharing of electrons is done. Sharing of electron is done. So when the sharing is done, then it is not that much stronger bond. It is like this. But in case of ionic bonding, it is like this. So in case of covalent bonding, it is like this. So it can be easily breakable. It can be easily breakable because it does not have any cation and anion involved. So it can be easily breakable. Then why carbon only do covalent bonding? Why not ionic bonding? If carbon transfer 4 electron to the other element, then what happens? If carbon takes 4 electron from the other element, then what happens? So if the carbon gain 4 electrons, if carbon gain 4 electrons and form C4 minus N, if carbon is gaining 4 electrons plus 4 electrons, if carbon is gaining 4 electrons from the other atom, then it becomes C4 minus. If it is gaining, it is C4 minus. If it is losing, then it is C4 plus. Carbon is having the charge of C4 plus. So first we are taking the case of gaining 4 electrons. If carbon is gaining 4 electrons, then it will become C4 minus anion. And how it look like in the atomic structure, that is, this is nucleus. This is the outermost electron, which is having 1, 2, 3, 4. There is one more shell, 2 electrons. So total there are 6 atomic numbers. So I have shown 6 dots. Atomic number is 6. That's why I have drawn 6 dots. 2 in the innermost shell and 4 in the outermost shell. And when it gained 4 electrons, then the electron will be 8 here now. 4 plus 4, 8. Now, it would be very difficult for this nucleus to hold 6 protons. If 4 electrons are added, then 6 protons are already there. And in the center, we have 6 protons. So it will be very difficult to hold on to 10 electrons. You know, for example, if there is a room which is having a space of only 6 students, can we accommodate 10? And if we accommodate 10, then it will be very difficult for, if that capacity is 6 people only, 6 students only. So if we add 4 extra, then what happens? It will be very difficult for that home to tolerate those 4 people. It can disturb all of the students. So 6 protons, for 6 protons, it is very difficult to hold on to 10 electrons, which is quite difficult. This is the first case. And what about the second case? Is it clear? Okay. If carbon loses 4 electrons, if carbon is giving 4 electrons to the other person, to the other element, then it becomes C4 plus. Means the outermost shell does not have any electron left now. Outermost shell is empty. Now it will take a very high amount of energy. If you have to remove all the electrons in a particular shell, then you have to require much more higher energy than removing 1 or 2 electrons. So you have to remove 4 electrons. So it will be very difficult again. So it would require a large amount of energy to remove 4 electrons leaving behind a carbon cation with 6 protons in its nucleus holding on just to 2 electrons. If you have 6 rupees and you have to give 4 rupees to the other, so it will be very difficult to do your survival in 2 rupees rather than 6 rupees. So like that, it would require a very high amount of energy to give 6 rupees, to give 4 rupees. And how the carbon overcome this problem? The carbon overcome this problem by a very unique bonding that is known as covalent bonding, means the sharing of its valence electrons. Carbon overcome this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. Not just carbon, but many of the elements form molecules by sharing electrons in this manner. These shared electrons belong to the outermost shell of both the atoms and leads to the noble gas configuration, leads to attaining the noble gas configuration. Noble gas configuration means either the outermost shell is having 4 electrons or is having 8 electrons. In the next part, we will study how to make covalent bonds and how to make bonding in this chapter. So first we have hydrogen molecule. First we have hydrogen molecule, H2. Hydrogen always exists in H2. How we draw its structure, how we make its bond. So hydrogen is having atomic number of 1 and hydrogen is having the configuration of again 1. So we'll show 1 dot in front of hydrogen. And again we have 2 hydrogens, so we'll put some space in between these 2 hydrogens and we will keep 1 more dot here. So there are 2 dots, each is having 1 atomic number. Now how they share? Hydrogen is having 1 electron, the other hydrogen is having also 1 electron. So what happens basically? They share. They share means first hydrogen also gives electron to the other hydrogen and that second hydrogen also gives electrons to the first hydrogen. So how it happens basically, first hydrogen says that I want 1 more to get stable. It will be having now 2 electrons. First hydrogen is having 2 electrons. Now second hydrogen says if I give you, then you have to also give me. Like this. Now 2 dots means 1 bond. If you join 2 dots, then it is 1 line. So this forms single bond like this. So this is all about H2 molecule. Like it is shown in figure 4.1. Similarly, we have O2 molecule. Similarly, we have chlorine molecule. Similarly, we have N2 molecule. Like in case of N2, nitrogen is having atomic number of 5. Configuration is 2, 3. So write down N, symbol of nitrogen. Then again N, because there are 2 N, 2 nitrogens are there. And there are 3 dots. We'll write the dots like this. 1, 2, 2. Oh, wait a minute. One, 2, 3, 1, 2, 3, 4, 5. You have to show the valence electrons. Outermost shell में कितने electrons है? That you have to show over here. So how it forms the bond? Now the nitrogen is having 5 electrons in the outermost shell. So if it is having 5 electrons, either it will be easier to gain 3 electrons and get 8, which is the stable noble gas configuration. So it is like this. It says the other nitrogen, the first nitrogen says the other nitrogen that you give me 3 electrons so that I will be having my octet complete. And if first nitrogen demands, then second nitrogen also demands for this. You also give me 3, like this. Now both are stable now, and nitrogen. Now there are 6 dots total in the circle, common circle. So 1 bond, 2 bond, and 3 bond. 2 dot means 1 bond. So 6 dot means 3 bonds. Like this. Similarly, we have O2. Oxygen having atomic number of 8. 2, 6. It is having the atomic number of 6. Oh, wait. Nitrogen is having atomic number of 7. So it is 2, 5. So I have to show the valence electrons. And oxygen is having 8. It's correct. Just you have to replace 5 by 7 and 3 by 5. So oxygen is having 8. So configuration is 2, 6. Now how we form bond? O, and total we have 6 dot we have to show. 6 dots. LNCB you have to show. 1, 2, 3, 4, 5, 6, 7, 8. Like this. 1, 2, 3, 4, 5, 6, 7, 8. Now I have to show only 6. 6. Wait. I have to show only 6. Like this. Now, to complete the octet, the 6 demands 2 more. The 6 electron demands, the 6 electron oxygen atom demands 2 more, and the other oxygen also demands for 2 more. And it will become, now there are 4 dots means double bond. So oxygen, that's why oxygen form double bond with the other oxygen. Other electrons you need to show or you cannot show. So that's all about. In the next class, we will discuss about some other compounds, carbon compounds, how they form covalent bonds. So today is all up to here. Thanks a lot. Please go through this chapter, and if you have any doubt, you can mail me or you can write in the comment section. Thank you so much.